Glad you're here for Unintended Consequences, episode 15 for May 22nd, 2026. Closing the week with one final case study before the weekend. In a Montreal apartment in 2014, Ian Goodfellow sketched an idea on a napkin that would let one neural network critique another until both produced images no human could easily dismiss as fake. The goal was straightforward. Give computers the ability to imagine new examples of faces, objects, and scenes without needing millions of labeled photographs. Within 5 years, the identical architecture was being used to map one person's face onto another's body in video, creating the first wave of widely circulated deepfake pornography and political fabrications. Ian Goodfellow was a PhD student at the University of Montreal, working under Yoshua Bengio when he proposed generative adversarial networks. At the time, generative models such as variational autoencoders produce blurry or low-resolution outputs that fail to capture fine detail. Goodfellow's insight was to pit two networks against each other, a generator that creates images and a discriminator that tries to tell real images from generated ones. The competition, he argued, would force the generator to improve until its outputs became statistically indistinguishable from reality. The paper, Generative Adversarial Nets, was submitted in June 2014 and presented at the Neural Information Processing Systems Conference that December. Researchers saw immediate promise for data augmentation, medical imaging simulation, and creative tools. No one in the room that day discussed video manipulation or non-consensual content. The conversation centered on unsupervised learning and the long-standing difficulty of modeling complex distributions. The 2014 paper spread quickly through the academic community. By 2015, follow-up work at Facebook AI Research and Google Brain demonstrated GANs generating recognizable bedroom scenes and human faces at 64 by 64 resolution. In 2016, NVIDIA's progressive GANs paper pushed output quality to 1024 by 1024, making celebrity-style face synthesis feasible. Early adopters celebrated the results in conference talks and open-source repositories on GitHub. A small number of researchers noted that the same fidelity that made the images impressive could also make them deceptive, but these cautions appeared mainly in footnotes rather than press releases. The first public demonstration of face-swapping video arrived in late 2017 on Reddit, where a user released code that combined GAN-based face generation with traditional computer vision tracking. The Reddit post titled Deepfakes received over 100,000 views in its first week and spawned a dedicated subreddit that reached 100,000 subscribers within months. The software required only a few hours of source footage and modest consumer GPUs, lowering the barrier from professional studios to individual users. By early 2018, the same technique had been used to insert the faces of female celebrities into pornographic videos. One widely shared compilation reportedly accumulated tens of millions of views before platform takedowns. Political applications followed. In April 2018, a video of Barack Obama appeared to call Donald Trump a complete dipshit, created by comedian Jordan Peele and BuzzFeed to illustrate the risk. The causal mechanism was direct. The adversarial training loop rewarded any improvement in visual realism, exactly the property needed to defeat casual human inspection. Second-order effects emerged quickly. Newsrooms began questioning the reliability of video evidence, while dating app companies reported users demanding live verification calls to confirm identities. By 2019, estimates from Deep Trace Labs suggested more than 96% of online deepfake videos were non-consensual pornography, the overwhelming majority targeting women. Detection tools developed in response created an arms race. Each new detector trained on existing fakes simply taught the next generation of generators how to evade it. Major platforms responded with policy changes. Reddit banned deepfake pornography in February 2018. Twitter and Pornhub followed with similar prohibitions. The U.S. Congress held hearings in 2019, and several states passed laws criminalizing non-consensual deepfake pornography. At the same time, the underlying research continued under new names. style GAN, big GAN, and later diffusion models, because the scientific value remained clear. Some labs adopted responsible release practices, such as watermarking or limiting training data, yet enforcement proved difficult once code was public. Today, consumer apps can produce convincing face swaps in seconds on smartphones, and detection remains unreliable against high-quality outputs. The original GAN architecture has been largely superseded by newer generative methods, yet the core tension it introduced, easy synthesis of realistic media, persists. Open research into generative systems will continue to produce dual-use capabilities. The same objective function that improves medical image simulation also improves undetectable fakes. Institutions that fund or publish such work therefore need pre-publication review processes that consider misuse pathways beyond the author's original intent. Finally, once a generative technique reaches consumer hardware, retroactive controls become largely symbolic. The relevant question for any new generative model today is not whether it can be misused, but how quickly that misuse will outrun the safeguards built around it. That's unintended consequences for today. If this episode gave you something to think about, share it with a friend who'd appreciate the story. Subscribe wherever you listen, and we'll be back tomorrow with another case. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.